Hi everyone. Today I want to talk about the second part of my video where we learn how to predict stocks using machine learning. Last time we started using this data which contains daily stock price, daily values of the stock, the volume of the stock for multiple symbols. Here we see a snapshot with the Apple symbol. So this is the input data where we started with, and last time we learned how to create features from these inputs. And I'll link in the description below to the video if you want to learn how we created these features. We used sort of common indicators, just short and long moving averages, exponential moving averages. And in a twist for machine learning, we do need to sort of normalize these features, cannot use them as is, because we need to compare sort of different stock symbols. So we ended up with a data frame like this, where we have the symbol and the date, and for a given day and stock symbol, we ended up with a number of sort of features based on commonly used technical indicators. So that is where we were last time. And this time we make a further progress from that. We learn how to create the labels, which is a very non-trivial exercise. So we look at the next sort of what happens in the future, which is in the next 15 days, because this is a swing trading setup. And we have a target sort of price and a target sort of stop loss. Here in this picture, you can see a target sort of 5% sort of take profit target and a stop loss of 5% as well. So we start in this when we buy the stock at the open. In this is specified by this blue line, and we want to see if we can hit this target by the end of 15 days. If we hit the stop loss before that, we will term it as a negative label. If we can hit the target, then we will term it as a positive label. This is how we do the labeling, and then again I'll sort of explain that again in more detail when we do sort of the coding part of the exercise. So when we sort of do this code up this logic in Python, we end up with a set of labels for each day and symbol, and then finally we're able to go from there, train our machine learning algorithm, and we can see that when we choose like 5 stocks on a given day based on our algorithm, we get 4 of them right. That's sort of the what we will see at the end of the video. So now let's go and start coding. Okay. So this is a file that I will link in the description below. So check it out, and you can sort of reproduce everything that I have done here. Some of this, for the first part of this, is what we went through in the first part of the video series. So again, there will be a description, like a link below in the description, so you can sort of follow through that video. But I will just run through the first part as I execute in my notebook here in Google Colab. So we read the data, and again, this is a file that I have shared with everyone, so you can sort of take this. If you run this, you will be able to download this data for daily stock prices, and it's just taking a while to read this data, do some pre-processing, and you can see a little bit about the data. So it's shows some stock symbol and a bunch of prices. And then we learned how to sort of visualize this data. We took like a little slice of this data frame for Apple, and we saw how we can visualize this data. And then we had this code for technical indicators, which is sort of much more involved, and you want to look at the first part of the video to understand what we did here. But this is where we sort of calculated the features. And so the things that you need to know here is that in the end of the day, we ended up with a set of features for every symbol and date pair. And these are the features we had calculated. We can look at the other thing that is important here is that in the first sort of few days, the short and the long moving averages are sort of a placeholder value because we didn't have enough days to calculate it. And this is data that we are going to sort of eliminate when we train our machine learning algorithm. Same for the Bollinger score because we didn't have enough time to calculate the moving average and the moving standard deviations. So the part that I'm going to talk in detail today is about generating the labels. So we will start with a sort of more visual explanation and then see how to sort of write the code for that. So let's take a little slice of the Apple data frame. So this just contains like 20 data points from the Apple data frame. So the setup that we have here is that we start on January 5th. And what we're going to do is to buy a stock on the first day where we start, January 5th. And then we're going to set a profit target, which we set at 5% here. And we're going to set a stop loss, which again, we set at 5% here just for illustration, but this is sort of this is a parameter that you need to specify yourself. And so you can see the Apple stock price here. And then basically what we do is we buy here, which is at the open price. We can check what that price was. Maybe we check. Okay, that was 181.99. So we did this, and then, okay. So 181.99, and then if we make a 5% profit, we go and sell the stock immediately. If we hit the stop loss before we make that profit, or if we never make that profit and we make a stop loss, we sell the stock at a loss. That is the setup that it's a swing trading setup. That is the setup we are using to calculate the label for our machine learning algorithm. But this is not the only way to do it. It depends on how you are trying to trade, and you have to create a label based on that logic and reasoning. But here we will use this setup and learn how to create the label based on that. So if we visualize, we can see that in this case, our label will be 1. It's a binary classification problem. It's either a 1 if we sort of hit the target before we hit the stop loss, and then it will be a 0 otherwise. So it will be time consuming to calculate it for our whole data set for every symbol. So we'll start with a very small data frame to illustrate the process. And then this contains only 3 symbols that we have handpicked. And so we will first start with a simpler problem where we find the maximum percentage gain and percentage loss in the next 15 days. And this is 15 sort of business days when the stock market is open. So it's like more like 3 weeks, basically, unless you have a holiday. And then, in any case, we calculate that, and then we will tweak this code a bit if we want to get our labels. So how do we do this? So first we create this gain loss list, and then we do a group by symbol. And when you do a group by in pandas, this is something that is not very trivial. So basically, what happens is, if you look at the panda sort of doc, if we do a group by, and you can iterate through all these groups, you can print the name of the group, which will give you this the column that you grouped by, and then the group itself is just the data frame, which contains only rows corresponding to that group. So for example, like the bar and the foo are like the column A, we group by column A. So all the ones with bar will be sort of the first group. And this will be a data frame with just this group. Now, let's come to the, so basically we get a data frame, which is this group here, and then we reset the index to be sort of 0 to 50, so 0 to the length of the group. And then what we do is we're saying if we get the open price for the first sort of day, and then we are saying if we have 15 days ahead of us, if our data frame contains 15 more days into the future, only then we do this calculation. If we don't have that data, then we just not do any calculation. Then we cannot calculate the label. So then we say what is all the future highs and what are all the future lows. And the max high is just the maximum of all the future highs. The min future low is just the minimum of all the future lows. And the max gain we calculate as the max of this future high minus the open price. And then we calculate a percentage, because the open price is where we start buying, and then we have the future highs and lows. And then for each time we are able to calculate this, we will append a dictionary to the list, which contains the date, symbol, and the maximum gain loss. And then finally, we will take that sort of list of dictionaries and convert that into a data frame. So what happens if we do this? So we calculated, we have three symbols, because we selected those three symbols for our small data frame. And let's look at NVIDIA. We chose this because, during the first part of the year, it had a huge amount of gains and very little loss in each of these sort of dates, which you can clearly see. Which, if you see Apple, again, you'll see sort of more modest gains. And this is the example which we visualized, where we had sort of 7.9%. And you can clearly see that that was above the 5, sorry, where did we do this was above sort of the 5% boundary. So I think this was probably like 7.9% starting from here. So that makes sense to us. Now we will take this. Now we'll take this code and do a little bit of tweaking. What is the tweaking that we will do? So first of all, we have two parameters. We have a gain percentage and a stop loss percentage that we need to set. And then we have to ask ourselves if we hit the stop loss before we hit the gain. If we never hit the gain, so our label is 0 if we never hit the gain. And our label is 0 if we hit the stop loss before we hit the gain. But if we hit the gain and we hit that before we hit the stop loss, then our label is 1. That is the distinction that we are making. So let's take our previous code and modify and tweak this a bit. We define a different list called the label list. We again do the group by, go through each group, only calculate if we have 15 days of future data. We calculate future highs, future lows, max high, max low. And this is where we calculate the arg max, which tells us the index at which the high happened. And this tells us the index at which the low happened. So now we can calculate again the max gain and the max loss like we calculated before. And we start with a label of 0, which is a negative. We say, if we don't have any other information, the label is negative. Then we ask if we went above the gain percentage. If we never went above sort of the gain percentage, which is like 5% here, then our label will be 0. So we are not going to do anything. So if it happens, then there are a few things that we need to check. The first thing is the stop loss. So if we never hit the stop loss, so if our minimum loss was larger than the stop loss, so as an example, let me show you our stop loss is minus 10 here. So this would be like 10% change. If we never hit the stop loss, in that case, our label will be 1. And again, if we hit the stop loss, but so if we hit the stop loss, but we made our future high was before we hit the stop loss, which is the future low, then our label will be 1 again. So there are sort of two cases where the label is 1, where like this is the case, we definitely have to satisfy, we have to be above the gain percentage. And then if we never hit the stop loss, it's 1. If we hit the stop loss, but we hit the, but it's, but we hit the high before we hit the stop loss, then we are good. Um, so then what we do is, instead of getting the max gain and the max loss, we get the label. And then we construct a data frame with the label list. And we can look at the data frame clearly with NVIDIA and like 5% gain. Clearly these are, 1 because we always hit these gains. We can look at a more, a stock where this doesn't happen. So we look at the VOO, which is a S&P 500 ETF, which is way more stable. You won't find this very large sort of moves within 15 days for these. And you can see that it's only here it gets to 5%. In some cases, it never goes to 5%. It's sort of 0. Here it's sort of 1. So that's the so this tells us that we are doing the right thing by looking at the data. So what we will do now is just wrap everything up in a function, whatever we did till now. So we have the price data, which contains multiple symbols, and then we have the gain percentage and the stop loss percentage, and these are the parameters that you are going to set as a user. So once you set them, we do the exact same things, and we return a data frame of labels which contains a symbol and the date and the label, and we eliminate the max gain and the max loss because we don't need that. So this is what we do. So now we need to get all the different symbols. So we'll get all the different symbols for which we have all of the data. We filtered the data frame, and then we join the features and the labels and run our algorithm. So we are trying to find symbols for which we have all of the data. There are some symbols which are, more flaky, like sometimes we don't pull the data for those. So this is sort of a more data cleaning question. So if I look at some of these symbols, it seems like we have data for 133 days. I'll just check this. This is a slightly, I would say, lazier way of doing it, but even for Apple, we have 133 days. So clearly we have, I think Apple is a fairly well-known stock symbol. So we will have data for all of the days for Apple. So we will try to find, so let's first we will make sure that we have the same random seed so that you can replicate all of the calculation here, because we will randomize some of the calculation below, as you will see. So what we want to do here is we want to find symbols that have all of the data for 133 days. If there are sort of less well-known symbols for which we have incomplete data, that will eliminate those sort of symbols. And then we'll do that, and then we find that we have sort of 4,918 symbols for which we have this data. The problem is the way that I have set up the code, it will take a while to run through all of those 4,918 symbols. So I will select a few symbols at random. If you want to do this in practice, you might want to not select random stocks, but you might want to sort of trade stocks of more established companies. But here I will just select a random set of stocks, and now you realize why I chose a seed, so that I could replicate all of that calculation. So okay, so we have filtered, we've selected the symbols, and we have filtered out the data corresponding to only these 100 symbols. Now what are we going to do? We're going to call this all technical indicators function. You remember we did this in our last video where this is the function where we called it with only Apple, and we got these technical indicators. Now we're going to call it with these 100 symbols, and we're going to get back the results. Let's see, where were we? So okay, feature df, and then okay, so that gets me the features. Okay, so the problem here is that, as you saw before, and this is a thing that I mentioned at the beginning of the video, if you look at the tail of this data frame, this is all right when we look at the later dates, but for the beginning of the data frame, which starts from January 2, um, we saw that we didn't have enough data for like the long moving average and the Bollinger score and so on. So we do want to eliminate these data where it's like 1 and 0, because those will sort of make our algorithm like add noise to our algorithm. So we have this filter. We remove all the rows where the long MA is equal to 1 and the score is equal to 0. So that will get us, yeah. And then, okay, so we will make one choice here. We will look for, so we are looking for a 1% gain. We'll put the stop loss at 5%, but that is a choice that it's not something that you can, it's something that you have to make a choice as a user, and this is something you should play around in your, during sort of optimizing the algorithm. So with that choice, we get a label data frame, and you can see already it takes a few seconds to calculate the label. If we were to sort of push all of the data here, that would take forever. So now let's look at the feature and the label DFs. As you can see, the feature DF filtered has much less data because we eliminate about like more than 90 days of data which don't have the moving average. Okay, so, and then, and now this is the part where we sort of combine all of the data that we have to train a machine learning algorithm. So what we do is sort of inner join in SQL terms. We inner join these two data frames, and the way to do it in pandas is to use the merge function, and we will only look at sort of symbols and dates for which we have feature and label data. And then, okay, here we go. And you can see like the feature data is not there for the first part of the data frame where we cannot calculate where we don't have the past data to calculate the moving average. And the label data is not there for cases where we do not have the future data to calculate the labels. And so the sort of intersection of those is less than the feature and the label sort of sizes, which you can see in this, yeah. And so we will look at the head of the data frame, some random sort of one of the random symbol that was chosen, and you can see we clearly see the values of the feature and the labels here. One sort of general note of caution when we train some of these stock prediction algorithms is not to do a train test random split, because then you have the data from the future which appears in the training data, and that is not good, because you want to predict what is going to happen in future and time. So if your training algorithm already knows, for example, it already knows data from sort of June 20, it's trying to predict what will happen on May 14, that is not a good thing. Because you do not want to pollute you do not want to give the algorithm information about what is going to happen in the future. So we're going to clearly split the past and the future when we're going to do the train test split. So we're going to sort these values by date. We're going to find the columns here. We set the 70% of the data into training. We're going to find the number of training examples is like the total length of the feature multiplied by the percentage we set. And so we're going to set like 1300. We have like 1800. Yeah. And so 1300 is going to be training, and the other sort of 600 is going to be test. So that's what we did here. So our training data frame is 0 to like this 1316, and then 1316 to the end is going to be our test data frame. We know the feature columns because we saw the columns here. We explicitly state what are the feature columns we want, and this is the label column, which is label. And so if we want to train a machine learning algorithm using the sklearn library, we need to change these into sort of matrices or Numpy arrays basically. And as you can see, we divide it into train and test. So we have these 7 features. We're going to sort of take these feature columns from these data frames, and calling values would make it a NumPy array from a data frame. Same with the test. We're going to take the test data frame feature columns. These are the features of the test. And then the Y is the label, the training Y is the label columns values, and the test Y is the test DF's label column. So we can use either a random forest or a gradient boosting. You can sort of play around with each of these. And then we've already set the seed before, so we don't need to set the seed here. So we're going to call a gradient boosting classifier with n, so 25 estimators, that is 25 trees. If you do not know what a gradient boosting classifier is, this is something you can look up sort of on the sklearn sort of page or a machine learning textbook. But basically, it is a collection of trees. It has 25 trees. Each of the trees we specify the max depth to be 4 and the maximum leaf nodes to be 4, and this is the random state we specify. So that is the classifier, and basically it is going to construct 25 different trees, and each of the trees is basically when you construct the first tree, it will try to make a more rough estimate, and then the next tree will try to fit the residual from the previous tree, and this is how it will go on. And I have a blog post about this. If you want to check it out, I'll probably link it in the description. But yeah, so this is the here we fit the training data, and now what we want to do is to predict the probability of each of the test cases. So for each of the examples in test, we're going to predict the probability. We're giving the test X as all the features. We take each row as sort of if set of features for one symbol and date, and then we're going to get the probabilities for that. And we get about 565, and these are, if you want to check what these are some numbers between 0 and 1, saying that like how likely the label is to be 1. So actually it shows the probability of being a 0 and the probability of being a 1. So we have to choose the second column if we want the probability of being a 1. So we need to choose a threshold. So if the value is above the threshold, we will call it a label 1. If the value is below the threshold, we'll call it a label 0. So we choose a threshold of 0.6. So for example, this row here is going to be a label 0 because the probability that this label is 1 is 0.37, which is below our threshold. For second example, it will be above the threshold. So you can see what is the, like if we look at like the test DF, the first sort of 10 rows of the test DF dot I log 0 to 10, that should show you like these are, so this is the symbol, this is the date, and these are the sort of labels, and then you can see what it did, what is the prediction it made. And sometimes it makes a correct prediction, sometimes it makes a wrong prediction, and so on. So we choose a threshold of 0.6. We're going to, yeah, and then we get the symbol and the date from the test DF, and then the second sort of column, which from this one tells us the second column here will tell us this one will tell us the probability of being 1, and then the true label is the test Y, which is the label column from the test DF. And then what we're going to do is we're going to say if the prediction is 0 or 1 by comparing the prediction with the threshold, and it will give sort of a Boolean value, which we convert to an integer. So it'll be 1 if true, 0 if false. And then we're going to check if the result is correct by comparing the prediction with the true label. And again, we'll do an astype in to get zeros and ones. So this is what this does. And now we want to see what happens at a given date. So the challenge here is that you do not want a more traditional machine learning evaluation. You might want it, but it depends on how you are trading and what is your objective. So here, what we're going to do is we want to look at the unique dates here. So we have 612 is where the test DF starts. So we're going to check what happens if I trade in 612. And the way that I am going to make this trade is like, I'm going to take 5 stocks which are like the highest sort of ranked, the highest probabilities. And then I'm going to trade on those 5 stocks. So I'm going to take the 5 best sort of results from this algorithm, and then I'm going to trade those stocks. And so all that I care about is how did it do in those top 5 stocks. I don't really care about accuracy or ROC curve or so on, which traditional machine learning does. We would want to design our own sort of evaluation criteria. And that could be a sort of a separate video that I probably would make in the future in terms of how we sort of evaluate these and in like systematically. But let's see what happens here. So we choose 612 as the date. We want to know how would we have done on 612 if we used this algorithm. So we sort our values by the prediction probability. So we take the ones, the ascending is false, so it's sort of sort by descending values. So the top, so we say that this is the one which think has the highest probability, and this is the one we think is the next highest, which are the same here, and then so on and so forth. And then these are the 5 stocks it says has the highest probability of winning on the day 612. So we pick these stocks, and then we are asking how many examples are correct. We're saying we're taking the correct, and then we're taking a cumulative sum of the correct. So how many of these are correct? If I choose the first stock, how many is correct, and so on. So if I choose only one stock, like 0 is correct because the prediction is 1 and the true label is 0. So we got 0 correct if we choose only one stock. And then if we choose 2 stocks, the second one has a true label of 1 and a prediction of 1, and we get 1 correct. So the total number of correct is 1 if we choose 2 stocks. If we choose 3 stocks, again, we'll get 2 correct, and so on. So that is the cumulative sum. And then we want to find the total examples, which is the length of the list, which contains the range from 1 to the total number of examples. And then we want to divide the two, and we get the top K accuracy. So if we choose only one stock, we get total number of examples is 1, we get 1 correct, so our accuracy is 0. If we choose 2, we got 1 correct, and we choose total of examples is 2, we got 2 correct. If we choose all the 5, we got 4 out of the 5 correct, so our accuracy is 0.8. So depending on how many you would choose, probably 5 is a reasonable number. You would choose the top 5 stocks, and you would want to be correct there. As long as you are correct on the top 5, you don't really care about the other ones. So we run this, and this is where we are. And so that seems to be a fairly good algorithm. So on the day 612, what it would have told you, we set the threshold at 0.6, and that is a number you want to optimize. And if we followed this algorithm, we would have bought this stock, and this stock. And again, I don't know what they are, but they are one of the randomly chosen 100 symbols, because they're above these threshold. You would have said, I don't want to trade these stocks because they're below the threshold. So, and then you would have been wrong with this one, but you would have been correct with these ones. And that would have helped you sort of recuperate the losses with the one that you were wrong with. And then you want to do sort of a more extensive evaluation of multiple dates and so on in this way, so that you can get an accuracy. And then you also want to change some of the parameters to sort of optimize that accuracy. We do want to look at one thing, which is how good is it at sort of separating out the probabilities that it predicts for the 0 and the 1 label. So this contains the predicted probabilities for the cases where the true label is 0, and this contains the predicted probabilities for the cases where the true label is 1 with like the blue color. And if we draw this, what we can see, it's doing a slightly better job here, where it's saying that these the zero ones, it's giving like the peak is at a slightly lower probability. So in some cases, it's basically it's picking up some of the yeah, basically what I'm saying is that it's giving lower probability to stocks which are in reality labeled zero, and a slightly higher probability to those which have a higher which are labeled one. But at the same time, it's overlapping, so it's not clearly doing like a perfect job or anywhere near perfect. So there's a lot of room for improvement here. Just wanted to check. So we have a lot more zeros here, which is why the zero which is in red has a higher sort of peak. So that was it, guys. We were able to go from um, an input which was basically a, let's see, if we scroll up, we were able to go from an input which was basically saying bunch of stock symbols, dates, and what is the open close values and volumes and so on. We were able to go from there. We were able to construct a bunch of features, labels, and we were able to join together those features and labels. And let's see, yeah, features and labels to construct our data frame. And then we were able to apply a machine learning algorithm to give us to help us make trades. Basically, we were able to find top 5 stocks, and 4 of them out of the 5 it got sort of right, based on this algorithm on this particular day. We don't know how it's going to perform on other days, how sort of a more systematic evaluation will do. But thanks a lot for joining, and if you find this useful, like, make a comment below, subscribe to my channel, and like my content. Thank you.